Hello everyone, welcome to new class. Today's class is the continuation of mesh analysis by inspection method. So let us discuss some more problems related to the mesh analysis by inspection method. Let us go through the problem. Find V by mesh method such that the current through 5 volt is 0. So we have to find the value of this voltage, and given that current through this branch is 0. So first of all we have to select the current. So let this current be I1, this one I2, and this be I3. So given that through this 5 volt current is 0, that means I1 is equal to 0. So I1 equal to 0 means by Cramer's rule we can write I1 is equal to delta 1 divided by delta, and that is equal to 0. That means delta 1 is equal to 0. So here we need to find the value of delta 1. So for that we have to write the matrix form. So in matrix form R11 is the total resistance in the first loop, that is 1, 2, 3. Then R12 is common to first and second loop, that is 1 ohm, and its direction is I1 in this direction, I2 opposite. So through this one I1 minus I2 is flowing, so this is minus 1. Then R13 is common to first and third, it is also 1. I1 and I3 are opposite, so this is I1 minus I3, so we can write minus 1. Then R21 is same as that of this one, that is minus 1. Then R22 is total resistance in the second loop, that is 3. Then R23 is common to second and third, that is 1, and current through it is this I2 is flowing in this direction and I3 opposite, that is I2 minus I3 is flowing here. So here also it is minus 1. Then next row R31 it is also minus 1. R32 that is 32, it is also minus 1. Then R33 is total resistance in the third loop, 1, 2, 3. So this is the resistance matrix. Then the unknown currents are I1, I2 and I3, and that is equal to the voltage in the first loop is, here there is 5 volt and here minus V volt. So in this direction, if we are taking in this direction, this is positive 5 and here this is plus 2 minus, that is minus V. So we can write 5 minus V. Then in the second loop there is no voltage source, so 0. Then in the third loop, I3 is flowing in the same direction as that of V, so we can write V. Now we have to find I1. So I1 is equal to delta 1 divided by delta, and here it is given that I1 is equal to 0. So delta 1 is changing the first column of the resistance matrix with the values of the voltage matrix. So we can write 5 minus V, 0, V, then minus 1, 3, minus 1, minus 1, minus 1, 3, and find its determinant and equate it to 0. And this is delta 1. So delta 1 is equal to this one. Now we can find the determinant. So we get 5 minus V into 9 minus 1, then minus of minus plus 1 into 0 minus plus minus of minus plus, that is V, then minus 1 into 0 minus 3V equal to 0. Now we can simplify this one. So here we get 9 minus 1 as 8. So 8 into 5 is 40, then minus 8V, then plus V, then minus of minus plus 3V equal to 0. That is here 40 minus 4V equal to 0. That is 4V equal to 40, or we can write V is equal to 40 divided by 4, that is 10 volt. So this is the value of V. So in this way we can do the mesh analysis. So this is inspection method of mesh analysis. Let us do another problem. Using mesh analysis, find the value of V2 such that the current in 2 plus J3 ohm is 0. So this is an AC circuit, and given that the current in 2 plus J3 ohm is 0, that is current through this branch is 0. 2 plus J3 ohm is here, and first of all we have to select the currents. Let this be I1, then I2, and in the third one, here it is given that plus is here. So if we want, we can select the current in the anti-clockwise direction, that is I3 in the anti-clockwise direction. Now we can draw the matrix. So in the matrix R11, R11 is the self-resistance in the first loop, that is 5 plus J5. Then R12, that is common to 1 and first and second loop, that is J5, and its direction is I1 in this direction, I2 opposite. So this one will be the difference of I1 and I2. So this minus. Then R13 common to first and third loop is 0. Then second loop R21, R21 is same as this one, that is minus J5. Then R22, that is self resistance in the second loop. Here 6 ohm and 2 ohm, that is 8. Then J3 and J5, that is plus J8. Next is R23, that is common to second and third, 6 ohm, and its sign here I2 and I3 in the same direction, that is this is the sum of I2 and I3. So here this is positive. Then next row, that is R31, R31 is common to first and third, 0. Then R32 is same as this one, 6. Then R33, that is the total resistance in the third loop is 6 plus 4, that is 10. Then the unknown currents are I1, I2 and I3, which is equal to, in the first loop voltage is 30 angle 0 and current direction is same as that of the source. So we can write 30 angle 0. In the second loop there is no voltage source, so 0. Then in the third loop it is V2 and current direction is same as that of the source, so it is positive V2. Now it is given that 2 plus J3 ohm current, that is the current in 2 plus J3 ohm is 0, means I2 is equal to 0. I2 equal to 0 means delta 2 divided by delta is 0, that is delta 2 is equal to 0. So we need only to find delta 2 and equate it to 0. And before that, here this is in rectangular form. So first of all we have to convert this rectangular form into polar form. So before that, let us write delta 2. So delta 2 is, change the second column values with the voltage values, that is 5 plus J5 minus J5 0, here 30 angle 0, then 0 V2, then here 0, 6 and 10. Its determinant is equal to 0. Now we have to convert these rectangular forms into polar forms. So to convert this rectangular form into polar form, let us use a calculator. So this is 5 plus j5. So in 991 ms calculator, here shift polar of. We have to convert 5 plus j5. So 5, comma 5 bracket then equal to. So magnitude is 7.07 and to find the angle alpha f equal to, that is 45 degree. So 7.07 angle 45. Then next we have to find minus j5 to polar form. So for that shift polar of, here minus j5. So the real part is 0. So 0 comma minus 5. The bracket then equal to, that is 5. Then to find the angle alpha f equal to, it is minus 90. So we get 5 angle minus 90 as the polar form of minus j5. Then the remaining magnitudes values are entered. Now we have to find the determinant. So for that 7.07 angle 45 into 0 minus 6v2, and next one we get minus 30 angle 0 into 5 angle minus 90 degree into 10, then minus 0. Then next one is 0 and equate it to 0. Now we can simplify. So here we get 42, that is minus 42.42 V2, then angle 45. Then here we get minus 150, then into 10. So 1500. So 1500 angle minus 90 equal to 0. Because here in multiplication we have to multiply the magnitudes and add the angles. So 30 into 5 into 10 is 1500 and 0 plus minus 90 degree is minus 90 degree. So from here we can find the value of V2. So V2 is equal to 1500 angle minus 90 divided by minus 42.42 angle 45. And here the magnitudes we have to divide and angles we have to subtract. So 1500 divided by 42.42 is minus 35.36. Then angle is minus 90 minus, that is minus 90, then minus 45, that is equal to minus 135. So V2 is obtained as minus 35.36 angle minus 135 degree. And here you can convert this polar form into rectangular form, and also you can find the determinant in rectangular form also. Either you can convert all the rectangular forms into polar form and find the determinant, or you can convert all the polar forms into rectangular form and then find the determinant. So in this way we are doing the mesh analysis by inspection method. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.